Okay, so let's. So the semester you are done with the semester. Fine. Okay, that's great.
Hey, how's it going, Jeffrey? Everything good? Is it? You can hear me okay?
Done with the semester.
Uh, no, in about 2 weeks. I have my final exam in 2 weeks. But I have final exam review on Tuesday. But I got a 98 on my test that I had on Tuesday. So,
Excellent.
yeah, I'm doing really well in that class.
So what I'm going to do is like starting the organic chemistry,
Right. So I'm
but
going
during the
to,
organic
let's
chemistry, I will
see,
also review
just a
sometimes
moment, okay?
like some little time on the general chem, which they are going to include in the organic chemistry test. Okay. Okay. So now let's today we are going to start the organic chemistry, real organic chemistry. So let's start with this. First of all, what is I already told you in the last time. Organic chemistry deals what thing? In the carbon compound. In the past, the scientists believed that organic compounds are only prepared by the living organism, and we can't prepare those compounds in the lab. But accidentally, they one of the compound ammonium cyanide they prepare from there.
Okay,
They
we
prepare
can
the urea. Urea was
start
like the
whenever you're ready.
first organic compound.
I'm all set.
It's chemistry of
You're set.
carbon. Chemistry of carbon compounds. Carbon compounds. And now we can prepare a lot of organic compounds are prepared in the lab. And each year the number of organic compounds are increasing.
Okay.
It's in the millions. That's why they made like a separate branch for organic chemistry. Some of the compounds
Well,
which we were already studying in the other branch of the chemistry like carbon dioxide, carbon monoxide, carbonates, we still
it's the
study in
study
our,
of chemistry of
but
living
majority of the
systems
compound, the
and
vast majority,
of carbon,
we study in the organic chemistry.
carbon
Today I'm
compounds.
going to start with the nomenclature or naming of the organic compound called nomenclature. Naming of organic compound. Of course, there are common names, and but the common names do not work as we move to the more complicated compounds. And of course, we can't memorize the million of compounds, the name of the million of compounds. So they started a very systematic name called IUPAC naming. This is a systematic naming of compound. We do not have to memorize the compound's name. We know we had learned the method, the rules, how to name the organic compound, and we can give the names without memorizing the things. IUPAC system of naming. And IUPAC stands for International International Union of Pure and Applied
Okay.
Chemistry.
Nomenclature.
Pure and Applied Chemistry. Sometime in different books you are going to see like a different way of naming the compounds because they are modifying their system of naming. So sometimes some books we use, they do not have the up-to-date naming system. So it doesn't matter because teachers, if it is okay, then teachers don't mind those things. But let's start with this. First of all, organic compound, as I told you, is a compound of carbon. The simplest organic compound, the simplest organic compound family, you can say, organic compound family, a group, are hydrocarbons. Hydro, hydrocarbon. The name tells that they are made up of two elements, carbon and hydrogen. Only two elements are there. If is there any other element, they are not hydrocarbons. So hydrocarbons are the compounds made up of only carbon and hydrogen. No other element is there. These are the simplest hydrocarbons, are the simplest organic compound. Now before we go to the other thing, like carbon makes four bonds. How many bonds? Four bonds. How we know it's four bonds? Let's take the electronic configuration. Carbon has atomic number 6. This is general chemistry. 1s2, 2s2, and 2p2. I'm writing this according to the Aufbau principle, putting the electrons from lowest energy orbit shell and orbital subshells to the higher energy shell and subshell. Now in this case, the valence shell is this second shell. The highest number of principal quantum number like 2 is the highest. So this is the valence shell. We are not considering this, we are just looking at this valence shell. S has how many orbital has S? 1, and P has 3. So 2 electrons are here, and according to which rule I have to put the electrons separately with the same spin.
Okay.
Or no, Aufbau principle is arranging. So you're right, and this normal condition of writing the configuration, we call it ground state. Next time I'm going to just write shorthand GS. So how many unpaired electrons you see here?
Right.
2 unpaired. So unpaired electron is equal to 2. The number of covalent bonds formed by any atom depends on number of unpaired electrons, number of single electrons. So we have 2, it means carbon can make how many bonds? 2 bonds.
Okay.
In the ground state. But practically, in most of the carbon compounds, carbon makes 4 bonds. How we can explain this thing?
How many orbitals
This
has
anomaly?
S1?
We can explain by going to the excited state. In the excited state, what happens? Carbon is moving one of its electron from 2s
Aufbau principle.
to the empty p orbital.
No.
And now we have how many unpaired electron we have? 4 unpaired electrons. Yeah.
Okay.
Now, so 4 unpaired electrons. That's why, because in excited
2
state,
unpaired
carbon has
electrons.
4 unpaired electrons. That's why carbon makes 4 bonds, 4 covalent bonds. That's why we call it tetravalent. Tetra means 4, tetravalent, 4 bonds.
Carbon
Yeah, they
can make
comes.
2 in the ground state.
Yeah, actually, what happens in actually we are going to introduce one topic,
Right.
hybridization. Okay, hybridization is like a theoretically you can say like a mixing of orbitals, of different energies
Now we have 3 unpaired electrons, or 4 unpaired electrons, including that
energies
2s2. Yep.
to give same number of
4 covalent bonds. Okay.
of hybrid orbitals. Hybrid orbitals
So what ends up happening is it gets excited and it
of
jumps to the
equal
next energy
energies.
level, the electron. Is it just
Same,
transfers?
sorry. Same like, let me explain this. Of orbitals of equal energies. What it means,
Okay.
let me explain this thing. Yes, we
I
did,
don't
but
wanna
just
jump-
we have
I
to
don't wanna jump ahead
revise those things
of
for
how you wanna
organic
go.
chemistry. For example, carbon is making here 4 single bond, CH4, 4 single bond. Also remember that all single bonds, single covalent bonds, when I'm saying bonds, are sigma covalent. Sigma covalent bonds, sigma, denoted by like this symbol sigma. In multiple bond, like double, triple, like that one, in multiple bonds mean double or triple.
To give
Only
some number
one
of
sigma is
hybrid
there.
orbitals.
Only
The same number.
one sigma bonds, and the remaining bonds
No problem.
are pi bond. Pi bonds. Pi bonds like pi. We are using as a symbol. Pi bonds. For example, if it is double, how many sigma bonds are there? 5. For example, I am taking carbon,
Covalent
and this is like, of course, they always make 4 bonds in most of the organic compounds. How many? Let's take this carbon. How many sigma bonds this carbon is making? Which I made a circle. All singles. Yeah, this one, this carbon. But if you are no, this is I am pointing out. This is not a bond. This is arrow I am using. I am asking about this 3. That's right.
1 sigma bond, 1 double bond. I'm sorry, 1
3
pi
sigma
bond.
bonds. That's correct. How many pi bonds? 1 pi. And the total is still how many? 4. Am I right? What about this carbon? CH4 at the top.
Which one? The okay,
4
the circle
sigma
around.
bonds. And how many pi bond there?
So I see this one here is making 1, 2, 3,
0,
4
pi bond.
sigma bonds.
All sigma bonds, all single
Hold on.
bonds are sigma.
This one.
Now
This one.
let's explain this. What about
Right.
this one? Triple
So
bond.
this one's making 1,
Carbon
2,
making like
3,
this.
4
What about this
sigma
carbon?
bonds.
How many
and this
sigma
one
bonds?
here is 1 pi bond, right? So that. Oh, and this, if this one is also, then this is a sigma bond. Is this?
You're right. 2 sigma bonds and 2 pi bonds. Now, whenever we
Okay,
are
only 3.
going to look like the
1, 2,
hybridization,
3.
you do not
3 sigma
include
bonds
the
and 1
pi bonds electrons. You only consider the sigma bond electron pairs. So now let's start with this.
1 pi bond.
You already know carbon in the excited state. 1 has 2
4 bonds.
2s2. In the ground state, it has
Which
2
one?
unpaired electron.
This one. So there's
In the
1,
excited state,
2,
it has how many
3,
unpaired electron?
4 sigma bonds. 0 pi bonds.
No, atomic. Sorry, I made mistake. 2 electron, 2 unpaired electron. This is ground state. In the excited state, I told you 1 electron from here, and now we are making. I am taking the
This one
example
here,
of
1 sigma
CH4.
bond, 2 sigma
CH4.
bond.
Carbon
and
is
2
making
pi
4
bonds.
sigma bond. Am I right? 4 sigma. In this case, because all of them are unpaired and all of them are going to make sigma bonds, I am going to say how many s orbitals are here in the mixing. 1s, right? 1s orbital. And how many p orbital are mixing? How many p orbitals are mixing here? No, here. Just I made a rectangle here. How many p orbitals are here?
I'm sorry. I'm
So
just
we are mixing
trying to. I was just
1
writing the
of
notes
s
here,
orbital
and I got
and
to this
3
point.
of
So this 6 carbon. So
p
you're
orbital.
asking
Am I
me,
right?
this has how many
So
unpaired
total how
electrons?
many we
1,
are
2.
mixing? 1 and 3, total 4. So you will get after mixing 4 orbitals.
There's 4.
Whatever you are mixing, if you are mixing 4 orbitals in the beginning, even after mixing you will get the 4. But now you are not going to say it S or nor you are going to say like P. What you are going to name these orbital after mixing, you are going to say sp3 hybrid orbitals. Yeah, 4 is the number of orbitals. 4 is the number of orbitals. But each orbital is known as what?
1s. There's only
sp3
1s
hybrid
because
orbital.
it's the carbon.
Why we are saying S? The mixing, they are showing the mixing.
How many p?
That
Second?
these hybrid orbitals are made up by mixing one s orbital and 3 p orbitals.
sp2.
Okay. Let me I will give you some common examples, not from the chemistry. For example, you have a container where you have cold water. Suppose the cold water has a less temperature, 10 degrees Celsius.
Yes.
Another water you have like a hot water.
Total of 4.
Okay. And this one we have 40 degrees Celsius. Suppose you have 5 liter here and you have 1 liter here, the hot water. Now you are transferring both water, hot and cold, in a big container. What will the total quantity now?
4 sp3 hybrid.
6 liters. So total quantity remains same after mixing, right? 5 plus 1 is 6, still you will get the 6. But what will be the temperature of this mixture? 10, 40 or something else? And less. Okay, and suppose you are putting your hand after mixing. Are you going to see like here 10 degree, here like 40 degree? No. All of them are going to be the same temperature, am I right? The same thing happening here. Before mixing, S orbital has lower energy, P orbital has higher energy, but after mixing, all of the orbitals have now equal energy. It's like, and the number of orbitals remains same. Before mixing we have 4, after mixing you have to get 4. Just like the total quantity remains same, 6 liter. Is it clear? The same. Now in reality, actually orbitals are just, we are assuming these mixtures. Otherwise orbitals are not like a solid road or something. It is just imaginary, you can say the region where electrons are found. Yeah, cloud. So actually this mixing is we are using to explain the thing. But what happens actually
it'll be
let me explain this.
Greater than 10 degrees.
Right now in the ground state, carbon can make how many bonds? 2 bonds. So whenever an atom make bond, it release the energy. Suppose one bond is giving 10
Right,
energy,
right.
10 joules. Suppose a kilocalorie. So two bonds will give you 20 energy, am I right? Suppose one, whenever you make one bond, one, yeah,
Right, okay. I can see that. Yep.
no, absorb it, and yeah, and make the bond, give energy. So look, giving energy is you are getting some profit. Whenever you make like two bonds, it is just like you are making two
Yes.
apartments to sell, am I right? So you are getting 20 kilocalories energy. But in order to unpair this one, they are already paired. You have to spend energy. If you want to unpair this one, you have to spend energy. Suppose you
It's
are
like a
spending
cloud,
energy
right?
7 joules. How many energy you are spending? 7 joules or 7 kilocalorie. Any unit you can take. 7. And after making new extra bond, you are getting 10. So you have profit or loss.
2.
You are spending 7 to unpair this thing, and now you are by making an extra bond, you are getting 10 because you are making two extra bond. Am I right? Profit by 3. So that's actually happening. So they,
Say again?
when there is a less consumption for unpairing,
To
and
make the
as
bond,
a
it
result,
takes
when you are
energy,
making
and
more bond,
break
you
the
get
bond,
profit.
it
That's
gives
happens.
off
But in order
energy.
to explain,
Right?
we use the word hybridization, mixing of. And this mixing of orbitals will give you the equal energy orbitals, and equal energy orbitals are known as degenerate orbitals. Equal energy orbitals are called what?
Mm-hmm.
Degenerate orbitals. And now you can put them according to the Hunsu because all of them have same energy. So whenever,
7.
remember this very simple rule, they will ask you this type of problem. Whenever carbon makes 4 sigma bonds, 4 sigma bonds and 0 pi bond,
Mm-hmm.
remember the hybridization is going to be sp3 hybridization. What hybridization is going to be there?
Oh yeah, you profit by 3.
sp3. And structure is going to be tetrahedral. sp3 means tetrahedral shape. Tetrahedral shape. And the angle is going to be 109.5 degrees. Now the next is, let me take
Mm-hmm.
this one. C double bond C H H. You already told me like in this case, carbon is making 3
Degenerate
sigma
orbitals.
bonds and 1 pi bond, am I right? Total is always 4. Total is always 4. Now the hybridization is going to be, I am writing the excited state, S and P3, single, single, single. How many pi bonds you are making? 1, right? So just exclude the last one, pi bond, electron which is involved in pi bond. Do not include that one into hybridization. Include only the sigma bond, the electrons which are going to make sigma.
SP3.
These are going to make 3 sigma bond. So now the hybridization is sp2. What is the hybridization? Because you are not including the pi one, sp2 hybridization. And always remember, sp2 hybridization is going to be, you don't have to write and weight those things, just look the how many sigma bonds they are making. If carbon is making 3 sigma bond, 1 pi bond, just remember it is sp2 hybridization. And sp2 hybridization means the structure is going to, shape is going to be planar triangular shape, a triangular shape, a triangle you can say shape, and the angle is going to be 120 degree. The next one is carbon with triple bond.
1 pi bond.
In this case, I am not writing the whole thing. Carbon is making 2 sigma bond and 2 pi bond. Bonds. 2 pi bond. Now the hybridization is going to be sp, because you have to exclude one more, and now only sp2
SP2.
sp hybridization. and the shape is going to be linear straight line structure, and the angle is going to be 180 degree. That's how we recognize. Let me, I will ask some question from you. I am asking this one. C double bond O. C double bond O. H C H H H. Can you tell me about this carbon? What is the hybridization of this carbon?
Mm-hmm.
sp2, very good, because there is one pi bond, three sigma bonds. So hybridization is going to be sp2. What about this one? sp2. So you can easily identify them. It's not big deal, okay? So now I'm giving you another one more. CH. Yeah, okay. I asked, yeah, just because you are recording, because I also recording, but my recording is not going to include the white. Okay. So that's why it's better you recording with the voice. Okay. Okay, now look here in this one more I'm giving you. C triple bond N. Now what is the hybridization of this carbon?
Hybridization of this one? Okay, let's see. 1, 2, 3. So I'd say sp2.
Yes. Linear shape, 180 degree. Am I right? So it's very easy to identify them. Just look sigma and pi bond.
This one.
Yes.
Okay.
It asks those things also.
sp3.
So I'm going to combining like both. I'm doing main organic chemistry together, and also
just
slowly going to the
paper.
general chem things, which you have to do in the
Okay.
organic chemistry. Okay. Yeah.
Yeah.
So it's no problem. We will
I'll
go
write
through
them
those things,
later. I'm recording
and if you
this,
think some
okay?
extra things when your
I'll,
class, we will
yeah,
do.
I'll worry about noting.
So this is,
later
I'm
on.
going to stop
I'll
here
pay
for the
full
organic
attention to this.
general chem part,
Yeah.
and now I'm going to start the real
Okay.
organic chemistry. Before doing those things, first I'm going to
Okay.
here, and that is,
Yeah,
as I told you,
I can
nomenclature,
send it to
naming.
you as well.
Naming is called naming of
Yep.
hydrocarbon. I'm starting with, especially I'm starting with the naming of alkanes. What are alkane? Alkane are the most simplest
It's
family.
sp.
Hydrocarbons,
It's,
and in the
linear,
hydrocarbons,
180 degree
alkanes.
angle.
Alkanes contains all
Yep.
all single bonds. All.
Is that stuff that
What
we're
would be
gonna
the
have to do?
hybridization?
They're gonna start. Okay. Mhm. Yep. Yep. Very good.
Yes,
Yeah, we have plenty of time to do this.
And
so,
alkanes contains carbon, and because example of hydrocarbons, alkanes are also
Yeah.
hydrocarbons.
That's
So
fine.
it contains
That's fine.
two elements,
Yep.
carbon and hydrogen. And remember, the naming which we are going to do for alkanes is going to be used for all other organic compounds. So you have to understand alkanes properly. All other names we have to just modify a little bit here and there. Okay. So basic is going to be alkanes naming. So I'm writing the alkanes naming, some common one, like alkanes name I'm writing here, and I am writing it. Okay, also be careful, make it clearly A, because sometimes even I make mistake, like my A looks like E, like sometimes. But whenever you are naming the organic
All
compound,
single
be
bonds.
careful. A and E will take the compound.
SP.
Okay.
Or sorry, if they're
You have to
I
be
mean, if it's,
very careful about that. A and E.
well,
A and E.
okay. Well, if they're all covalent,
So I'm writing
it'd
the
be-
first
and they're all
CH4.
carbon, so it would be sp3.
One carbon alkane. The name of this carbon is methane. ME. Now I'm writing E. And now at the end I am writing ANE, clearly showing ANE. Methane. Next name is
Yeah.
C2H6. Another name, you have to memorize these names with the
Okay.
yes for the class, because all the other chapters naming are going to base on this. All the other chapters, even in the part 2, part 1 of organic, basic is going to be the same naming. Yeah.
Oh, okay. 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 Oh,
Yeah,
okay.
ethane. Now look, I'm giving the general formula. The general formula of alkane is CnH2n plus 2. N is the number of carbon atoms. For example, if N is equal to 1, you have 1 carbon atom. How many hydrogen atoms should be there? No, N is 1. Four, 4 hydrogen.
They're gonna have
2 times
for
1 is 2
class.
plus 2,
Okay.
4 hydrogen. Look here, 4. We don't write 1, but it is carbon is 1, hydrogen is 4.
Okay.
Now if N is 2, how many hydrogen
Yeah.
should be there? If N is 2.
Yeah, I noticed like for the second semester of that
6.
chemistry
Look,
course,
C2H6, can
they
you
were
see?
sticking on like all those certain acids and bases. You know what I'm saying?
Like make
Okay.
the, whatever
So
the
this will
number of
be,
carbon atoms, make it
alkanes,
double and add
methane,
2.
and
Now I'm not writing the
ethane,
formula, you are
or
going to tell me
ethane.
about the hydrogen. How many hydrogens are going to be here? Yeah. Yeah. And this name is called propane. Propane. Be careful writing the A very clearly,
2.
because if it looks E,
I'm
you
sorry.
will lose the
N
point.
is 1. Okay.
Now what
So
about
there's
C4?
2N
How many hydrogen?
plus 2. So there's, is that 4N or okay. Okay.
And its name is butane. Butane. Now C5 will give you how many?
6.
12. Yeah.
Okay, so
All this
CnH2n
contain.
plus 2.
Pent means 5, penta means 5. C6, how many hydrogen?
Okay, so if we make it 3, so it'll be 3
It's going to be
plus
hexane.
3 times 2, which is 6, plus 2 is
Hexane.
8. So 8 plus 3 is...
C7, 8,
Okay.
C.
Oh, okay.
It goes even 1000, but we don't have to worry about it. We are going to go like 10. Right now I'm going to go only 10. And no, definitely the organic compounds, the
it'd be
polymers
10, but,
contains
I
even
just wanted to
10,000,
make
like the
sense of it here.
proteins,
So 4 plus,
in our
2
body,
times
they
4
are
plus 2
organic
is
compounds
10.
containing
C4H10.
10,000
Okay.
carbon atoms. So we don't have to worry about it. For your example, you have to just go 10, and we are going to go 10 right now. Okay. After that,
C5 should give us
F10,
12,
you're right.
5
F10.
times 2 is 10, plus 2 is 12.
And
Pentane.
what should be named?
Yep. 6 and 6 is 12, plus 2 is 14.
Yes, right. Octa. So from octane.
This would be 14, 16.
The ending is
Yeah.
ANE.
How many can it go to?
The ending is ANE. What about C9H20?
The
It's
carbons,
no name.
it can be...
All
go
of
up to,
them
you
are
said, the
ending
thousands?
at ANE. No, 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 no. Yes, I put the wrong
Yeah.
number.
Wow.
See, 10H22 is D. Sometimes
Is this
people call decane, some
is this
decane.
heptane?
So like,
Okay.
so
So
we are,
C8.
now we
So
are
would
going
that
up to
be
10. 10 is
C8H
sufficient. But after
18?
that, for example, if it is, you already know, like 11, we say UN, we put, and then
Let's
undecane,
see. Hepta,
dodecane.
and then
So the main name is up to 10.
let's
So
see.
don't worry about it. Okay.
Not octa.
So these 10 you have to memorize, and
Let's
it's very
see.
easy, not difficult.
Is it octa?
Okay. And now I'm
Octane.
writing the
Octane.
alkyl
Oh, okay.
radicals name.
Wow.
That was the alkyne, and now alkyl radical. And if as a symbol we use R. For alkane you can say RH. So what is the difference between alkane and alkyl radical?
No
If you
name.
take out
Oh,
one
okay. I thought
hydrogen,
you meant no name.
take out one hydrogen. Let me have a
No
look.
name. Okay.
CH4, am I
Cool.
right?
So C.
If I remove
9,
one
H
hydrogen,
20. Okay.
putting 4, now this become radical. Why? Because now it has a free vacancy. Like suppose a team,
Oh wow.
like I don't know
So
about
for organic chemistry, how
different
many
types of
do we
teams.
are we
Like
going to
football
go up
teams
to? Like
is
a couple
11
dozen?
players, I think. Okay. If one player
Okay.
is missing, you can substitute that. Right? One vacancy is there. Similarly, if one bond is free, you can place some element like X, Y, Z on this one. So without one
Okay.
hydrogen,
Great.
that's called radical. One hydrogen short, one free vacancy is there.
I'll
So the
memorize
alkyl
these.
radicals name is, you just get rid of alkane name,
Alkyl
remove the
radical.
ANE name
Okay.
from the name, and add YL. So for example, CH3, one hydrogen is less, am I right? So its name is going to be METH. Instead of ANE, you have to put YL, methyl. Am I right? I am removing the ANE and putting what? Y. What about the ethane? What name should be there? Eth. Yes. And what should be the formula? 2H5. Just make one hydrogen short. Ethane is
Right.
C2H6. Am I right? What is ethane? I just one hydrogen and put one free bond here. Okay, but one more thing. What about the propane? Radical name. Prop. Just YL. And its formula is going to be dash C3H how many? And so on. Butyl, pentyl, like
Yes.
that one. One more thing, going back here, or going here. For example, this radical, what we gave the name, this one?
Yes, you're correct.
Ether. I can also write the
Ethyl.
same thing as
Like
by
ethyl
opening this one.
alcohol.
CH2, CH3, the same thing.
ETO.
Instead of
no,
combining
I don't
them,
know.
I am putting them together like this. Why? Because I told you that each carbon makes how many bonds?
Yes. Ethane is C2H6.
Always look
Okay.
that side it is straight. 4.
Oh,
So I am making
okay.
4 bond each carbon. Now look here in the end. At the end, this carbon has 3, this carbon has 2. And because there is a one
like
free valency,
like propylene.
so
or
look this.
yeah.
This is CH2 radical. Is clear? Yeah. This is the free valency.
C3H7.
Some other element can join. Butyl. Okay, let's see. Butyl. What is the formula for butane? Let's say. Okay, so just make one H9. And how we can
Which
write
one?
this?
C2H5,
In the beginning, you can
we
write
gave that,
CH2.
let's see, ethyl.
Then again CH2. Then again CH2. and at the end you will write CH3. Look here, at the end you have CH3, am I right? Because here, let me I will show you here. CH2. Another is
in the
CH2.
ground state or the excited state? So ground.
Third,
4.
like expanding it. This is, all of them are same. Expanding it, making collapsing it like that. But basically they are same.
Oh.
Look here.
Oh, and there it
This is
That's the
CH2
red
or not? This one.
And
First one.
And it ends right here. You said
CH2,
okay.
right? This is also CH2.
What would butane? Butyl?
First one is also CH2. The last one is always what?
C4H10.
CH.
But it's going to be
That's how.
C4H9.
Like sometimes we have to open it. We don't have to writing like this one. It's like structure formula. This is a condensed structure formula. We are not showing the hydrogen, but separately. And now one more thing. When you are counting the number of bonds, this carbon is making one bond here, am I right?
Let me see. So,
One bond here. How many total bond here? 2. And each hydrogen makes single bond. So
Wow.
2 hydrogen means 2 more bonds.
So this is like a
2
different.
bonds,
This
3
is like
bonds,
a
4
factored.
bonds. Am I right?
It's like we.
This
It's
again
like we.
2,
It's like
3,
we took
4.
this.
And 1, 4.
C4H9.
Always they make 4 bonds. If they are making 2 and 1, 3 and 1 bond is free. One has to join. That's how we write these things. Now let's go back to the naming again. And
Yes.
at the end they will go CH3.
CH2 and CH3. CH3.
Yeah, just you add more thing. And one more thing. Go back here, which I gave you the name. If you look this series, let's go back here. The name I gave you. This is the first member of alkane. This is the second member of, third member, fourth member. What is the difference between what you are adding from here to here?
Mm-hmm.
CH2. You are adding CH2, am I right?
Mm-hmm.
You are adding again CH2, am I right? You are again adding CH2. So they have a difference of how much? The 2 consecutive members.
Mm-hmm.
The 2 consecutive members has a difference of what?
Mm.
Yes.
Okay.
And that's why we call this series as a homologous series.
So you have to
Same,
put it in form in terms of CH2 and CH3. Is that what they?
And they differ only
So
by
so that
differ
that's
only by-
looks like what this trend is: CH2 and a CH3,
CH2.
and then we're just adding CH2s to it.
And they have same general formula. They have same general formula. Look here, all of them are obeying the CnH2n H2n plus 2, am I right? So that's how we call it homologous.
We're adding carb. We're
Now
adding
let's
carbon.
go back here. That's
we're
name
adding
you have to
methanes.
memorize. I'm going
Wait. No, yeah, CH2. So it's
Look this one.
so it's 1/2 of.
No, don't worry about first you have to go by rule. Read the first rule.
CH2. CH2.
Now look here. This is 1, 2, 3, 4, 5. How many carbon if I take this one?
Homologous series. Okay.
5. But if I go here,
Yep.
and chain means continuous chains mean it doesn't matter straight line. For example, this is a straight line.
Carbon.
I can also
and
go like
hydrogen
this because it's continuous.
by
Right?
CH2. They only differ by
For
CH2.
example, I'm going like
Okay.
this, and here it is something else. So this is my substituent, a group attached to the main ring. It is just like suppose you are traveling to the highway, turnpike. Now it is an exit. Exit are
Right.
there. So that's exit actually. Here we are calling it substituent or group, treating them like that. So you have to look the longest continuous. Continuous means If you use your pencil, you can go from one end to another end without repeating it or without removing your pencil,
Yeah, find the
containing more carbon
longest
atoms. Is it
continuous
clear?
chain of carbon atoms
So
and
this
use the
case
name
we
of
are
this
taking because
chain
it has
as the
6
base
carbon,
name of the
other has
compound.
5. So I'm going to take the
Okay.
longest one. And now how we are going to give the name? Your main chain name is
Uh,
going to be
I
main
see
name,
5. Yep.
hexane. Why hexane? Because it has how many carbon atom?
Wow. Oh, wow, okay.
That's why we are giving the name hexane. Main chain. The final name is going to be main chain name.
Right.
Now this is outside of the main chain, am I right?
Okay.
Now you have substituent, a group, whatever you call it. Now in this case, what are the ending? This is the start and this is the ending, am I right?
Mm-hmm.
Either we can
Mm-hmm.
start here or we
Exit,
can
yep.
start from here. If I start from here, 1, 2, 3, the group substituent comes on what? Which carbon? Third. If I start from here, the substituent will come on which carbon? Fourth. You will give the number which give the lowest number for the branch, which is nearest to the branch.
Right. Yep.
That's why we are giving 3. And because
Got
like
it.
3 is giving you the position of CH3, like CH3 is attached to the like third exit at third place, that's right? It is, you have to turn here 6
Hexane
and
has
main chain has 6 carbons, so
6.
hexane. Why methyl? Because this group CH3 group is called methyl. One carbon is methane. From methane you can say methyl. Remove A and E and just put
Yes.
YL. Is it clear?
Substituent.
Now read this paragraph.
Yep.
Just keep 3 lines.
Yes. CH3 and the third.
And let me explain this. Suppose there are
The
2
fourth.
main roads, you are going somewhere, driving somewhere, okay? And the length is same. All of them are suppose 100 miles,
Okay.
100 miles. But this has only 2 exits
So we're giving
or 3 exits.
three.
The other one has
as
4
what?
exits. According to this rule,
Okay.
you will
Okay.
choose that chain which has more exits, more branches, more substituents.
Yep.
Okay. Let's like if you have like equal length, then choose that one which has more branches. So let's start this one. These two. This is 1. Yeah, 1, 2, 3. No, so I'm going to take this. How many
Yes.
exits are here?
Yep. The groups attached to the main chain are called
1, 2, 3,
substituents
4,
because they are
5, 6, 7.
substituted,
7 carbon main chain
substituted
and 3
in on the
branches,
main
3
chain.
substituents. Now look
When
this
there are
one.
two
1,
longest
2,
chains
3,
of
4,
equal
5,
length,
6,
use
7.
the chain with
Still the
the
main
greater
chain
number
has
of
7 carbon.
substituents
In
as the
this.
main
But
chain.
why that is right, why the other
Okay.
one is wrong? Yeah. More egg. Yes.
According to this rule, you will choose that chain which has more exits, more branches.
Yeah, exits. I am using the word
Mm-hmm.
is a group of radicals, whatever you call it. Okay. Yeah. Now look here in this case. This is the rule 2. Number the chain. Rule I already told you.
Yep.
Start the numbering from one end to another
So
ending,
there's 3 exits.
giving
So
the lowest possible number. Look here, if I go by here,
we have 3
the
exits
first
on
substituent
this road
comes
of,
at what?
or this highway of
3.
7 carbons.
If I go by here, 1, 2, the first substituent comes where? So don't worry about others. Look from which way you start your journey to get the
Yes.
exit very close. Because you are getting the branch closer from here at 2 number.
The other one
Here-
is wrong because it's got less exits or less
Which one?
substituents. So we want to take the
No, that's why the
the chain when we have 2 chains
Okay.
of equal carbons, We take the carbon chain that has the most substituents, and in this case,
Because
the
here
right
you are
chain
getting at
has
3,
4 substituents.
here you are getting at 2.
and we'll call it exits.
One more thing.
Yep.
Let me explain this. For example, 1, 2,
Group of
3,
radicals.
4. Okay.
Okay.
Suppose its chain is I'm starting from 5, 6, 7, 8. This is my main chain. Suppose here I am getting like CH3 group is here. This is my main chain. Suppose. Okay. My main chain. Another group is also here.
3.
So from where I have to start? Numbering.
At 2.
So don't worry about others. Look from which way we have started. You need to get the exact.
That's correct, because you are getting from 2 here. You are also getting 2 from here. Am I right?
But what about this?
Now I'm going to
What
here.
about this one?
This
How
one
come
I'm
you don't
getting.
start here? Oh,
Another
this
branch
is the
is
same.
here.
Oh, this is the same.
Now because 2, 2 is already balanced.
Okay,
am I
so
right?
this is
So
correct,
now we have
so
to look
wanna
at second
start here.
branch.
Okay, yeah, okay.
If I start from left to right, the second branch appears where?
Okay, this is telling me don't start up here, start down here.
If you start
Okay.
numbering from left to right, this second branch appears where? On which carbon?
Suppose the chain is I'm starting from 5.
Okay, what is the number of that carbon in the main chain?
This is my main chain. Suppose
4.
here I'm getting.
So if I start from left to right, the second branch appear at 4. Am I right? If you start from right to left, second branch is going to appear where?
So from where I have to
5.
start.
So if first branch is at the same position, look the second one.
Okay.
Because
let's see.
second one is nearest here.
1,
So I'm going to
2.
go by this method. Is it clear?
We could start at either end.
That's correct. Because we are getting
Side.
from
Because
here.
you have to compare. For example, other one is also same.
Mhm.
Now I'm going to
Here is also same. But the third one is giving 6. Here it is giving 5.
branches.
Then I'm going to follow this one.
Now because 2,
If 2 are equal, then look the third one.
so now we have to look
It's
at
clear?
second branch. If I start from
So that's how we give the name.
second branch.
So look the naming how they are using the naming. Let
I'm
this
sorry,
example.
say-
Let's see.
Repeat that.
Can I go back
If you
here?
start numbering from left to right,
Can you
Okay.
see this thing now?
the second branch appears where? On which card?
It'll appear
Yeah,
on
this
this
thing, whole thing.
Okay, what
So
is the number
here
of that card?
we are numbering from here. First
4.
substitute is appearing at first substitute is appearing at 2. Am I right?
The second branch
2.
appear at 4, right?
Another
Yes.
this is methyl.
Start from
When another substitute is coming
the second
where?
branch is going to appear where?
3.
5.
But this is not methyl. This is what?
So if first
It-
branch is at
ethyl.
the same position,
Now we are giving the name. Okay. Then at 4 we are again have methyl.
do by this method.
At 5 we have again methyl. How many
Okay.
methyl groups are there?
Right.
3.
If this was our molecule,
At
we
2,
would be starting
4
on this
and
side.
5 positions.
Okay.
Ethyl group we have only one.
The other one is also.
Why we are writing the ethyl first? Because ethyl start with
Mhm.
E.
But the third one is giving 6.
Ethyl starts with what?
Giving 5.
E.
Then I'm going to
So
follow.
always follow the alphabetical order.
Are equal, then
Because E comes before M. You don't have to look
Got it.
tri. Don't have to worry about tri.
that's how we give the
Tri, di, penta.
naming.
Don't. Just look the main name. Methyl.
This example.
Methyl starts with which alphabet?
Can I go back here?
M.
Sure.
Can you see this thing?
M. And ethyl starts with E.
Rule 2, number
So
the main
definitely E
chain.
comes before M. So you will first write the ethyl.
Yes.
3 ethyl.
We are numbering
2, 4, 5.
We're numbering from this
Trimethyl,
bottom.
because at 2, 4 and 5 you have 3.
Yes.
3 methyl group, and for 3 you are writing the word 3. Trimethyl means there are 3 methyl groups.
coming where?
At 3.
But this is not meter. This is what?
Ethyl.
Is it clear?
Meter. Now we are giving the name. Okay. Then at 4 we are again have meter. At 5 we have again meter. How many meter groups are
And
there?
remember,
At 2,
3.
4 and 5.
once,
Ethyl group we have only 5.
okay, so don't worry about this. If you understand alkane, all other organic chemistry naming is easy. Just we modify a little by things.
So always
Okay,
follow
so
the
this-
alphabetical order. Because E comes before M.
Yeah, that's better. That's why it is better
Don't worry about trying.
master those things.
Penta, don't just look the main name. Ethyl.
Yeah, no problem.
Ethyl starts with which?
And also because you want to plan to the medical
Methyl
field,
M.
and all the, if you look the medicines, All
Mhm.
of them are organic compounds. They give you name. So it's better.
3-ethyl, 2,4,5 trimethyl, because at 2, 4 and 5 three methyl group, and for 3 you are writing the word 3. Trimethyl is
Yeah.
the 3
Wow.
methyl.
Wow. Now I understand that. Now I know how to understand this stuff now. Now, yeah, that really. I never really knew
Okay.
what any of
So
that
look
stuff
here. This
meant.
one is going to.
I
Now I'm
always
going
would
to give
see
you
the
one another
different
one.
naming like that
Okay.
of all these
Sometime I'm going to
complex
make a
molecules, but
mistake,
I
and you
never
will predict my
really
mistake. Okay.
knew how to understand it. But now I do. Yep.
If you don't know what this is, and if you understand alkane, all other organic chemistry naming is easy. Just to modify a little.
This I should be able to master
It's
this
a-
before I even start the
Yes.
class.
Normally, for your
That's why
I want to master this.
yeah, but for your subject, it's
You're
going
gonna
to
help. Yeah,
I
you're gonna
don't
help
think
me
more
get
than
to
12 or
mastering this.
something. 10. First, I'm doing 10, then we are going to little bit.
and also
I will
because you
let
want
you
to plan to the
know
medical field,
further, but not too many you need.
all that
Okay.
you look at medicines, all
Right.
of them are organic compounds.
Right.
Give you names.
I never understood it when I was working in the
Yeah, we have
pharmacy. I
many
would see
functional groups.
the
We
small
will just deal
package
those later.
insert,
First, you
the
have to understand
manufacturer
alkene.
insert, and you
Then
unwrap
we
it,
will
and
do
it's
the
a
other things.
huge
Okay.
paper, and it's
So
got
let's
this
go back
fine,
here,
fine
and I'm
print of all
asking you
the
something.
explanation of all these
Okay,
molecules
I'm
going
doing
on,
something right
and
here.
I never really understood.
I'm
it.
writing
But,
CH.
yeah, this is opening up my eyes to how I'm going to go about understanding it.
No. It's a bond. It's not a negative sign. It is bond.
Okay, someday I'm going to make
It's
a
not a
mistake.
negative sign.
You will
Okay.
predict my mistake.
So these alkanes, these substituents, they're all.
Yes.
I know I'm going back up, but they were all either C2. They were all ethyl, methyl, like there were all those.
Yes.
But they can be higher though, right? They
Yeah, but for
propyl, butyl.
They are just the bond,
you're
not
doing 12 or
minus.
something, then first I'm doing 10, then we are going to little bit, I will let you know.
Okay.
But not too many. Okay?
So the alkanes will sometimes include an alkyl radical in the molecule.
Many functional groups,
Yeah.
we will deal those later. First you have to
Now
understand
look here,
alkane,
this one.
then we will do that.
I am writing the name. Okay.
So let's go back
1,
here.
2,
I'm
3, 4, 5,
doing something
6, 7.
I'm
I am giving the name
Joffrey,
4,5
methyl. That was
dimethyl
CH3, but that had a
dimethyl
negative sign before the C.
No. It's
heptane.
not a negative sign.
I also remember
A
that
bond.
I
Okay.
don't have to give the gap. You should
A
continuously.
bond CH3. So that's what methyl is.
system.
Bond.
What it is
CH3.
right or wrong?
Is that correct?
Correct? Or
Okay, thank
wrong?
you. No, I just I noticed that I missed that note, and I'm just gonna write that in
First-
there. So
Why it is
yeah,
incorrect?
referred to as bond.
They are just the bond. Minus.
Okay, so
Okay.
very good. So actually, I made mistake. I have to start from here. Am I right?
Now look at
It's
this.
3 because nearest
I am writing the name. Okay.
5,
1, 2,
6, and 7. So what will be the correct name?
5, 6, 7. I am giving the name 4, 5 dimethyl 15. But also remember, like, I don't have to give the gap. It's continuous. Your system. What it is right or wrong?
Uh, Just a second. Okay.
Yes.
So incorrect.
Even if I look
Okay.
like here, like this
So,
is also wrong.
First
If I
thing I
give
did
the
was I
space,
went left to right, and then I analyzed
going to be wrong.
from
Don't
right
give
to
the
left,
space,
the
okay?
carbon chain. So I went
Write the
1, 2,
heptane
3,
together.
branch, and then I went okay, right, 1, 2, 3, 4, branch.
And heptane
So I just
together
said
like
red
this.
flag. We should start here.
So actually, I made mistake. I have to
Yes,
start
main
from
chain. Right?
Yes.
3,
Let me. I will give you one more.
Yep.
5, 6, and 7. So What is the correct name?
Let me see. Just a second. I just want to see why this was incorrect. So we went 1, 2, 3. So okay. So we went 4, 5. So instead it should be 3, 4. So it should be 3, comma 4. Tac. Methylheptane. But let's see. So that's
Okay,
2.
give the name of this company.
Dimethyl. So these are methanes. So that's dimethyl.
Even if I look like here, like this is also, if I give the space, it's going to be wrong. Don't give the space, okay?
Okay.
Write the heptane together.
Okay. 3, 4 dimethyl. Boom.
Heptane together.
And then the heptane is this part, right? 1, 2, 3, 4, 5, 6, 7 carbon chain.
Yes, we
Okay.
Right?
Okay. Yep.
Let me will give you one more.
That makes sense. Methane radical is methyl.
Okay, give the name of this company.
Just a second, I'm writing it down. Okay, actually, I wrote it down incorrect, so I'm going to just pay attention here. So, let's see. Alright, so we're going to... Okay, so it's going to be 1, 2... This would be... Two, comma, 3, tac. Try.
Hello? Okay, what happens to the Skype? Okay, now correct. Okay, numbering is looks correct to me, but there is some problem with the naming. Okay, look here what you're writing here. That's correct. What try? 3-methyl group, am I right? But I see only the 2 position. when you have 3 methyl groups, you have to mention 3 positions. Mm. Mm. Methyl, that's correct. So always be careful when you are writing trimethyl, you have to mention 3 positions, even if they appear on the same carbon atom. Let me explain this
Yes.
thing. Okay.
I'm
For
not too
example,
sure.
if it is like
I
this,
have no idea.
CH3,
Is this correct or incorrect?
CCH3.
Numbering is looks correct to me, but there's
Okay,
some
no,
problem with that naming. Okay. Look here what you're writing here.
Try.
now
That's correct.
that's
But try.
okay. Now look here. This is my main chain, am I right?
Yes.
But I see
Now,
that
what will the name of this compound?
when you have 3 methyl group, you have to mention 3 positions.
Really? Oh. So, 2. Ah. Okay, so let me see. So, 2, 3,
Okay, you tell me what to know, right?
5. Try.
Okay, from which side I have
Okay.
to start numbering?
So always be careful when you are writing
Can you?
trimethyl, you have to mention 3 positions, even if they appear on the same carbon atom.
Wow,
Okay,
okay.
that's correct.
Yep.
And always put the number at the top, okay?
That was a good
So
lesson.
that we will not become confused with the number of carbon atom. Okay, that's correct.
CH3,
Now,
CCH3.
Thank you for this. I'm definitely learning right here
you have to give
for sure. The entire time.
you will no,
Okay, now look here.
you write 2 because both of
Yes.
them are at the same carbon.
Now what will the name
And
of
then
this
the last one is 3
Okay.
and trimethyl because
Let's
as I
see.
told you, like even if they are at the same carbon atom, trimethyl and 4 carbon means
Well, this
butane.
one's
Right?
B2.
Okay, you tell me what to do.
Tri means you need
I'm
3.
not too sure. I was thinking at first maybe it's just 2,
It tells like that
3.
one methyl is at 2,
trimethyl-
another methyl is also at 2,
trimethylhexane.
and the third
Oh,
methyl
I'm
is
sorry,
at 3.
trimethyl 3, 4.
Which side I have to start numbering?
Okay, what's
Okay,
wrong
we'll
with
start
if I
from-
go
yeah,
by
we'll
the
start from
opposite
there.
numbering?
So start numbering
Suppose I
from
will
1,
start numbering
2,
from
3,
this
4.
side. I am writing the name.
And always put the number at the
2, 3, 3, trimethyl. Is it correct or wrong?
Okay. And
Trimethyl.
then I would say the branch 1 is right here.
Yeah,
Branch
yeah,
2
right, wrong.
is
Because
well,
okay, 2 is okay.
I don't know, like that's
2 is
like
okay.
how
But
like
the next
how
part
do you
is 2 and
distinguish? Is it because there's 2 on the
so
side?
this is not correct. So this is wrong. Is it clear?
both of them are at
Sometimes
the
we
same
do, I will explain you the wrong thing also because sometimes we learn more from a mistake. Okay,
So you do mention it 2, 2. Okay.
okay, so is it clear this one?
carbon atom.
Okay, so now this is about one. Let's go
Okay.
back to here.
And no matter what, because of this distinguishing right here, we
Read
know
the
that
third rules you already.
that
These
all
are the
of
groups
them
which I
are-
already
that
told
all
you.
of them are the.
For
are the
example, this is
methyl.
methane,
Okay.
CH4.
Yep.
This is ethane, propane, butane. The groups are one hydrogen you are removing.
And just going by this
CH3,
name,
CH3,
we
CH2.
should be able to
At the
draw
end
this
is
out
CH3.
and get this structure
And
out, right?
here it is CH2, CH2. Butyl, pentyl, name is there. This is the common name of. Normally we don't use this, but at least you have to keep in mind. Pentyl is also commonly known as NMO. We will discuss later that. Now let's see this.
It would be wrong.
We already this one is
you've taught me so far.
the longest chain is this. We did this one. Methylhexane. This one is longest chain 1, 2, 3, 6,
This one
7,
is
8, 9. No name. You have at 3 position what radical you have?
I will explain you the wrong thing also.
Oh.
But sometimes we can more from the mistake.
Oh no, I know,
Ethyl, because 2 carbon.
Yep, and I like it.
At 6 you have methyl.
Clear this one?
Yep.
Why they are writing ethyl first?
This is about one. Let's go back to here. Read the third rules you already. These are the groups which I already told you. For example, this is methane, CH4. This is
Yeah.
ethane, ethane, butane.
Yep.
The groups are one pattern you are removing. CH3, CH3, CH2. At the end is CH3.
Mm-hmm.
And here it is CH2, CH2.
Mm-hmm. Mm-hmm.
Yeah.
Pentyl, pentyl.
Yes, you're right.
This is
Okay,
the
now
common name of.
I'm just modifying this.
Normally we don't use this,
That
but at least you have to know the key.
alphabet. Yes.
Pentyl is also commonly
Writing.
used as
It is ME, CH2, CH2.
we already, this one is, the longest chain is this, we did this one.
Mm-hmm.
It's a
Yes.
long chain.
Yes.
This one
Yes,
is the
I'm-
longest chain, 1, 2, 3, 6, 7, 8, 9, no 8. You have, at 3 position, what radical you have?
At the 3, we have radical is CH ethyl,
CH3.
Ethyl, because 2 carbon.
And now I'm getting
At 6
CH2,
you have
CH2.
methyl. Yeah,
Okay,
Why
main
they are
chain
writing
is what?
ethyl
Which
first?
one?
ethyl. They're writing the ethyl. So wait a minute. Yeah,
So
ethyl.
this is the main chain.
The ethyl
longest
is
continuous
coming
chain.
on the branch first. It's the first substituent of the 2. The second substituent is methyl. So
Which one I have
ethyl
to,
and
from
E
where I have to
is
start
before
numbering?
M. So if it's alphabetized, then it would be arranged in that order. Is it by alphabetic?
Yes, you're right.
Okay.
Now, I'm just modifying this thing.
Is it alphabetic though?
Alphabet, yes.
Oh. Okay. Okay. Mm.
Okay, let's start with this side.
So if these were
Let's see.
reversed and this ethyl
I
was
start
here
from
and
left
this
to
methyl
right.
was here.
The first group
Okay, so
appear
that's
where?
what-
First
So it
substituent
would be
appear where?
okay. Oh, okay.
If I'm going like this,
So it doesn't take precedence because it's an ethyl
main chain. So if I'm
over
starting from here, number,
methyl. Okay.
the first group or first substituent appear at which carbon?
Okay, main chain
So
is
if I start
The-
from here,
The ethyls will always be mentioned before the methyl. Okay.
this is the
Okay.
longest continuous
Okay. Okay. Yep.
from here,
So we
Doesn't
would still
matter
mention
ethyl and
this
methyl.
one first,
you start.
and then this, and
Yes,
then
it's
this.
going to be
chain. Which
three,
one after, from where I have to
but
start?
you don't have to write 3 methyl first. Writing, you always write alphabetically. Six, 7, 8, 9. What you will write first?
Is it this side?
Okay, let's start with this side. Let's see.
Wait.
Even if it is coming at 6, doesn't matter, but
First
ethyl
group
we
appear where? First
will get
substituent
give
appear where?
preference like methyl
If I'm going like this.
Okay, so this is the main chain.
and nonene. Am I right?
So I'm starting from here.
That,
The first
yeah, that's why I
first
changed that group.
substituent appear at
So you
which
don't have numbering always. You look like which one comes at the
4.
lowest number.
If I
Maybe
start
ethyl,
from
maybe
here,
methyl.
Oh,
But
I
when you are
didn't
naming, you
recognize
have to
this
put the
as
ethyl before
I'm
methyl.
sorry. I should have. I
Okay,
don't
alphabetical
know why I
order.
didn't. 1, 2, 3, 4. 1, 2, 3. We would start from here.
Ethyl.
Okay.
doesn't matter ethyl and methyl.
So it would
Now-
be 3.
These are some other groups
It's going to be
which you have to keep in mind because sometimes you
don't
need
have to
this.
write 3 methyl first.
Read this one. The simple branched
Writing, you
alpha.
always write alphabetical.
So we write
6, 7, 8, 9. What you will write first?
Okay, let me explain. Go back here first. For example,
6
I am taking
ethyl.
a group like this.
comma.
CH2,
Wow. Okay.
CH2,
Okay.
CH3. What you are going to call
It's
them?
of higher rank
This
and
group.
status. I'll consider it.
Right?
Yep.
What is the name of
Higher
this
rank.
radical or group?
Food chain.
So you don't have numbering always you look like which one comes at the lowest. Maybe ethyl, maybe methyl. But when you're naming, you have to put the ethyl before methyl. Alphabetical.
So this is methyl no name because of 9. Okay. Okay.
These are some other.
Don't just just count the propyl. 3 carbon means propyl. Am I right?
Read this one. The
So this is
Branch alkyl groups are usually known by
yeah
common names.
C3H7. Okay,
Isopropyl and isobutyl groups have a
C3H7. Okay.
characteristic iso
Now I'm asking another one.
CH3 2CH,
CH
just as in isobutane.
CH3
I-
CH3. Still how many carbon? 3 carbon, am I right? How many hydrogens? 7 hydrogen. But they have a different structure. They don't have the same structure. Here you have like all of them in the same line, starting from here going to the end. Here you are starting from here, like
just a
connecting
second,
from here,
just a second.
but it's not in a
This
straight
is
line.
going
It's
to
like a
be-
branch. Am I right?
Write it down.
It's not like connecting together. It's
So
like a one branch here.
If it were,
This
so
thing is called
C3,
iso.
H,
Iso. When like it is like this.
5, 6, 7. Okay. But
Uh,
it'll be
No,
ethyl. I'm sorry. No.
no. That's don't worry about it. This because
propyl.
is the hybridization there. We are not looking like that. That's making is different
Okay.
from 90 and 120. It doesn't
C3H7.
matter. This is carbon is making how many sigma bonds?
C3H7.
No, look again.
CH,
Yeah,
CH3,
one sigma here
CH3.
and one hydrogen.
Still
3 and also hydrogen is always make sigma.
Mm-hmm.
Rest it.
7 hydrogen.
Okay. So it doesn't matter that one. This is not making diagram line. This is showing the bonding. But look, this you can distinguish between these two.
Starting from here
Look.
going to the end. Here you are starting
Yes.
from here, like connecting from
Do you see the difference?
but it's not in a straight line, it's like a branch, right?
Right.
It's not like connecting together, it's like a one branch. This thing is called iso. Iso.
And now
it
can-
is like this.
Are those angles like 120 degrees?
Yes.
Or one.
Now in this
or like
case,
90,
of course you have
90,
the
and then
same 3
180.
carbons,
No. That's
but it's not in the line.
Okay.
is the
Is this clear?
We are not looking like that.
Suppose you are like here,
From 90
and now what happens? Your
Okay.
two sides you have friends, one side here, one side there, and you are making a
Two.
deal with someone, am I right?
again.
And
This
the
car-
other
this
situation is
carbon
you
right
are
here
making a
It's
deal,
making one
and your
sigma
friends
bond
are
here.
not here and there.
And then two
They are
here.
making it on your
And then
back
three.
side, all of
Three
them.
sigma bonds.
So that's called propyl,
Oh,
but
wow,
this
4,
one we
okay.
gave another special name, isopropyl. What we call it? We use the word iso, and because 3 carbon, so we put isopropyl. Now look, it's the same thing. Look here, CH.
Can I
I am
distinguish
putting
between
like
these two?
CH3,
Okay, so
CH2,
CH2, CH2,
CH3.
There's CH, but there's
Do
a
you have this
CH3,
group
so
or
it's a
not?
CH3, this CH2.
Still you have this
Okay,
group, am I right?
Yes. So this CH2 is really
Uh,
they're removing a
on
hydrogen.
both
and
sides
it's the
carbon,
radical
right?
is CH in the bond.
This is again iso, but now you have how many total carbon atoms?
But it's not in the line.
So instead of isopropyl, the total, including the other one.
Suppose you are like here, and now
Oh.
what happens?
So you are going to call isobutyl.
One side here, one
What
side
you are
here.
going to call it?
Mm-hmm.
You are making it
Isobutyl. Iso is just the 3 like this.
situation
One
is
carbon, and this is attaching like this one.
here and here. You are making it on your back side.
Isopentyl, yeah, yes, like that.
That's called propyl.
Or-
But this one we
Normally, when you are going further, it's not going to work too much, okay? So normally it's going to work only isobutyl, isopentyl most of the time. Now look here in this case.
now look, if
This is isopropyl, am I right?
CH,
And it is joining, when it is joining, this carbon has only one hydrogen, am I right?
CH3.
And the one group.
Do you have this group?
Yeah,
or not?
look here. This is, oh sorry, one thing I made mistake. Let me show
Do
you.
I have that group?
What
CH,
mistake I
So
did.
it's CH3,
Hold on,
CH2,
this
and
one is
CH.
CH2,
Both
CH2.
sides carbon.
Look here,
Right.
CH3, CH3. Can you see this one?
Now you have
So let me, I will fix my mistake. This is okay, no problem.
3,
The other thing is, I made mistake, so I'm going to fix this one.
4.
we are going to call isobutyl. We are going to call it
What I told you, isopropyl is this one, am I right?
just the three like this.
So isopropyl is always going to be that one.
This is attaching like
And
Okay, now let's see what
had
we can
five, would it
write
be
here for the isobutyl. Isopropyl.
Isohexyl.
Now isobutyl is going to be,
Normally,
this
I'm
isopropyl group is going to be there.
it's not going to work together.
This is going to be
Normally
there.
it's going to work
But the
with
only
isobutyl
difference is
pentane
the
three.
another CH2 group is
Now
going to
here
come
this
here.
is
This is
isobutyl.
isobutyl, sorry.
Right.
When it is
Isobutyl.
joining, when it is joining,
Like it
That's a
always
CH.
contains the isopropyl group.
right?
Can you see isopropyl?
It's joining at the methyl.
Yeah,
I'm
that side
sorry.
is going to be with the CH. This is isobutyl because you need isopropyl group. And now you have extra, and you have extra carbon, yes. And the further is going to attach from you. If it is like
Mhm.
one more CH2 is going to be isopentyl. Alright?
This is okay.
Because this is iso.
Other thing is,
So let's go back here. So look, isopropyl, isobutyl, and because if it is not radical, this is a free bond is radical. Without free bond,
Mhm.
you are going to call isobutane. Of course, this isobutane is not a IUPAC naming, common naming, but we also call it isobutane. Isobutane is just one more hydrogen with the isobutyl group. Isopentyl group, look here. This is iso group, correct? CH2, CH2, isopentyl. Is clear? That's how we the name. Okay. Beside these names, in all these cases, you will see the isopropyl group is always attached. Then you have more carbon like after this.
Instead of it being off.
Then
to
it
the
is
side over
isopropyl,
here.
isobutyl, isopentyl.
Okay.
Okay. But there is also another right.
This one here can handle that one, right?
Your extra carbon, yes, and the further is going to attach. If it is like
Isobutane is if it is not a free bond, one more hydrogen. That's not a
Yes,
radical.
'cause it will be
That's
five.
alkene.
Yep.
But this is not the IUPAC name.
back here,
Okay. Now I will ask one thing.
isopropyl,
I am writing this one.
because if it is not radical,
C
free bond is radical. Without free bond,
H3
called isobutane. Of course, this isobutane is not a IUPAC naming common name,
CH3
but we also call it isobutane. Isobutane is just one more hydrogen with the isobutane.
Mhm.
Isopentyl. Yeah. This is isobutane.
Yep.
is this is a isobutyl or not?
Pentyl.
Isobutyl group
Yes.
or not?
Yep. Ice.
Wait a minute. Isobutyl group or not?
You see the isopropyl group is always attached. After this, then it is isopropyl, isobutyl, isopentyl.
Just hold on just 1 minute.
So when there's
Hello?
more than one iso group, it would be isopropyl first, isobutyl, and isobutane, or no?
Isobutane is if it is not a free bond, one more hydrogen.
Okay.
That's not a radical. That's alkane. But this is not the IUPAC. Okay. Now next I will ask.
Okay.
I'm
So
writing
this is
C.
you're done. Hello, John. But something wrong with this when you are making. Can you tell me what's wrong here?
Is this is a isobutyl or no?
Hmm.
Isobutyl group or not? Isobutyl group or not?
The mistake is here, look. If I
let's
take
see.
this one,
It looks
it's
a little
making
bit
5
different.
bond. 2 bond with 2 hydrogen, 3, 4, 5. This is not possible. Now the one which I gave you here, this is, which I gave you here, is not a isobutyl. Because it do not contain this group. CH and it is making like
Okay. So this is
2 methyl CH. Yes.
you done? Hello, John.
Yes.
CH2
yes.
is going to have more than 4 bond. It
Wrong
means.
with this.
In this case, look, CH
Bonds here.
is here.
Let's see. So there's
One
two
here.
bonds
This is
here.
this is
3, 4.
isopropyl
So
group.
it can't
Right?
have this fifth bond.
isopropyl group,
this
and
is
the
incorrect.
CH3 is here. Am I right?
Because carbon can only, so it would be CH. Oh, okay, I
So
know.
look here
It'd
in
be
this.
CH,
This
and then
is
it would be
this is not a group. This is
CH2
not
over
a
there.
group. I have to write CH2 here.
Or
Mistake is here.
Wrong.
it's
Which is because group means it has a free valency. So if I make a correction and I will write instead of 3, I
Is
will
this
make
correct?
it 2. And
This is which I gave you here
now,
is not isotope.
yeah, now I'm
Because
making,
it do not
make,
contain this.
now making CH2, and now it is a
oh,
isobutyl.
I had it
This is
wrong. I thought it.
now it is isobutyl.
It is making
Now I'm asking another one. CH3. C.
I thought it was CH2, so I need to remember that the
CH2.
iso group is
C.
two
H.
methanes and
Is
two
this
two
is
methyls
a
and
isobutyl group or
CH2.
not?
So the CH2 is referred to as what again?
CH2 is going to be more than 4.
Or not?
Okay,
In this case, look, CH is here.
it's
One million
CH.
is the isopropyl group, right?
Yeah.
But no, but in that case,
We're not using CH2 at all. Oh, okay, I got you. Yeah.
yeah, it has to go here. This is not a isobutyl. This is not
Where?
because in ice you don't have, because isobutyl and iso mean it should contain exactly this thing.
And this will make
This
it
case
9,
it is
right?
not
The
like
9
this.
total. So then we'll
Because
have C4H9.
it has CH2, not CH3,
And that'll-
right?
And that is butyl.
That's why it is not. So now let's go the another naming here. That's
Isobutyl.
here.
Okay.
That's called some other alkyl group. We are going to use word one carbon. When it is only one carbon radical, we say is methyl group. You already know. Ethyl group, propyl group, isopropyl group. 4 carbons, butyl group. Also we call it isobutyl group. This one because iso group is there. But this is not iso. This
I
is
don't recall
secondary
seeing
butyl.
that in there.
When we
but I
use the
refer-
secondary,
But I'm looking
suppose
at
the
that
bond
as
is here.
the isobutyl group is right here.
Going here. CH.
But this here
Free
is,
bond is here. CH3 is here.
Something right here. That's
Here is also carbon. I'm not putting hydrogen.
This is not iso.
This
Right,
carbon
okay.
is making,
so it is not.
can make a bond. Am I right? Free bond is here.
Because isobutyl,
This carbon is directly attached with how many carbon atom?
And that's it. And then it will branch off into whatever it needs to.
this case
So-
it is not like this.
Okay.
Forget about hydrogen. Don't worry about it.
CH2, not CH3.
It is directly attached
Right.
with 2 carbon. Am I right?
That's why it is not.
We call it secondary.
Let's go to another name.
Secondary carbon.
That's called
Secondary
some
carbon.
other alkyl groups.
If it is directly, because
Use word
directly attached to
when it is only one carbon radical, we say is methyl group. You already know. Methyl group, propyl group, isopropyl.
H2 2 carbon atom.
4 carbons, methyl group.
Yeah, that's no. This carbon is secondary. This
This
one.
one because iso group is there.
Because yeah, even this. Yeah, you're right. Even this is secondary. But because we are looking the group,
Suppose the bond
so you have to look this one. This
CH.
this is, don't call this one because the group from where the something is attached. This one.
Here is also carbon. I'm not putting hydrogen. This carbon
Yeah,
is
these are the separate thing. Now look here, another one.
right. Free bond is here.
C
Right.
H3
Directly attached with
CH2 C.
That one's directly attached
H.
with 2 carbons and
CH2.
1 hydrogen, so it's full.
I am asking about this carbon.
Okay.
Is this a secondary or primary or
Yes.
It's secondary. Secondary carbon.
this is also secondary?
If it is directly
Now let me explain these things here on the blank pages.
Oh, okay. It's direct. Well, which one? Would this
Okay.
one be the secondary?
This
carbon
is
here?
called methyl. You already know the methyl. Okay. All 3 sides are occupied by hydrogen. Now another one I am writing here.
because
CH3
yeah, you're right. Even this is
C
secondary. But
H
because we are looking at group, so you have to look this one.
Okay.
CH
Okay.
No, sorry. This one.
Okay, and then these are the substituents.
CH2
This is
CH3. Sorry.
the group from where the something is attached.
Oh,
This is
okay,
free
so
bond.
only this,
This is free bond.
and this is the
Free bond is
substituent.
here. Am I right?
Yeah, these are the separate. Now look here another one.
Like because it someone else can join here. Am I right? here. So this carbon is primary carbon. This carbon is what? Primary carbon is that one which has only one side carbon, one directly attached carbon. One directly attached carbon. One directly attached
Now let me explain these things.
carbon. Am I right? No, I'm asking you, this is CH3's methyl. This is what? Methyl. But this carbon is attached with one carbon or not?
Sites are occupied by hydrogen.
Because hydrogens are around there.
I'm writing
We
here
are not worried about that. Now I'm giving you another one. CH3, CH2, CH2. What about this carbon? No second. Why? It is directly attached with only one carbon.
bond is here, am I right?
This carbon
You said
is
free
not
bond is
attached
here.
directly with it. It is attached with this one.
Can join here, am I right?
Mm-hmm.
Can you see?
This carbon
Let me, I will
is
explain this.
primary carbon. This carbon is what?
This is still primary. Let me, I will write this.
Primary
CH2.
carbon is that one which has
Yeah,
only
hydrogens are like here. Like
one directly attached carbon.
this one second.
Directly attached carbon.
Primary, right?
One directly attached.
Normally we consider the something which is has a free valency,
And
free
we
bond,
wouldn't
or
say that
something
this
attached
one,
with it.
the CH3 is
Okay.
primary.
So this one is primary.
This is CH3.
This one is also what?
This is what?
Primary. Now the secondary is different. Secondary
Yes.
is you are taking this bond,
The hydrogens are around there.
or this one, and now it has two side carbon. Two side what? Carbon.
CH3,
This is secondary
H2.
because it is directly attached with how many carbon atoms?
What about this carbon?
Two. Indirectly
This
doesn't
is
matter.
secondary.
Directly below.
No, sir.
And
It is directly attached with only one carbon.
we are not asking right now discussing.
This carbon
Okay,
is
we are
not
looking
attached
where you have free bond only.
This one.
It's clear?
Can you see?
So that's not, there's
what
no
would it
free
be,
bond
primary?
there, so don't worry about it right now.
This is still primary.
Now I'm giving you this one.
Oh, okay.
Free
So
bond
this
is
one
here.
here is secondary.
I am putting carbon here.
Hydrogens are like here.
So this one is
I am
this one
putting carbon
secondary.
here.
This
Carbon
is, and
here.
then this one's primary.
What about this carbon?
Okay. Okay.
Is
I
secondary or tertiary?
Normally we consider that something which is as a free valence.
It's a tertiary.
Something attached.
Now one more thing. Tertiary we write 3
This one
degree.
is primary.
Secondary we also write 2 degree. 2 degree means secondary. And primary we write 1 degree. Primary we write what? 1 degree. Same meaning. Now look here. In the primary, in the methyl. First let's start with the methyl. The free bond is here. Am I right? This carbon has how many hydrogens?
2. Okay.
It's a methyl. This primary carbon has how many directly attached
They wouldn't
hydrogens?
ask. They wouldn't ask. What is this
It's a
carbon?
primary. This carbon is also primary because it is directly attached with one carbon and it has directly attached with 2 hydrogens.
Got it.
This carbon is secondary because it is directly attached with 2 carbon. It has only, how many hydrogens are there? That's secondary. You can also identify by looking hydrogen. This has how many hydrogen here? 0 and directly attached with 3 side carbon. This is 3 valency. It is tertiary. Let's
Tertiary.
go and show you. This is butyl, isobutyl, secondary butyl. Why? In secondary butyl, this carbon, the free valency is with this carbon. 1 carbon directly attached, 1 carbon attached. Second. This carbon, where free valency is here, free vacancy is here, is directly attached with how many carbon atoms?
The free bond is here, right?
Hydrogen. So tertiary.
Yes.
This is 1 hydrogen,
This
secondary.
carbon is how many?
This is 2 hydrogen.
3.
Sorry, this is not an iso secondary. Okay, this is primary.
How many directly attached?
Is clear?
2.
We are also going to use these words. Look here in this case.
This carbon
Primary,
is also primary because
carbon, radical means carbon. Maybe carbon-carbon chain is going. R means radical. Radical like methyl, ethyl, propyl. So only one carbon is directly attached. 4 bonds are here.
hydrogens are there.
Only one bond is attached with directly with carbon, like here.
Also identify by
The others are not directly. They are going into chain.
how many hydrogens?
This is primary.
0.
This is secondary because two bonds are occupied by directly with carbon atoms.
Okay.
Radical mean carbon atoms. Look,
This is
one carbon
tutor
is here, one carbon directly attached here. Secondary.
in secondary metal. This carbon, the free valency is with this carbon.
In this,
One
one,
carbon directly attached, one carbon attached. Secondary.
yes, in
This carbon,
primary we have two
free
hydrogen.
valency is here.
In secondary we have
Valency is here.
one
This
hydrogen. In
directly
tertiary
attached
you
with how many
have,
carbon atoms?
3 and 0 hydrogen.
yeah. Now look
Tertiary.
this question
One
first.
hydrogen. Secondary.
Read
This
this
is two
question.
hydrogen. Sorry, this is not an iso secondary. Okay, this is primary. Yes, clear?
Yes.
We are also going to use this, but look here in this case. Primary carbon, radical means carbon. Maybe carbon chain is going. R means radical. Radical like methyl, ethyl, propyl.
Okay.
So
Now
only
we have
one
to
carbon
make
is
this
directly attached.
structure.
Four bonds are here.
How we can make this?
Only one bond is
Okay,
attached
first
with carbon, like here. The others are not direct.
it is opposite. Right now I gave you
This
the
is primary.
formula structure and you are giving the name. It is opposite.
Two bonds
Now
are
they are giving a name and we have to make the structure. First write the first name.
radical means
4
carbon atoms. Look,
isopropyl
one carbon directly attached here.
Uh-huh.
Second.
Now in these
octane, right?
cases, are these hydrogens just single hydrogens?
I am
Or do
writing
they,
this. I'm
or do
going
they
to the
represent?
free
Well,
page.
yeah, because it would only be one hydrogen can only make one bond. Okay.
I'm writing here. Okay.
In second
I'm
we
writing
have
this thing.
one hydrogen. In
Oh,
tertiary,
okay.
4
0, 2, 1, 0. Okay.
isopropyl
now look this question first.
octane. First main chain
Okay.
contain how many
Question
carbon
1.
atoms?
4 isopropyl octane has a chain of 8 carbons. With
Okay, I'm
an
not putting hydrogen
isopropyl
right now. I'm
group
just putting
on the
hydrogen.
4th carbon.
I'm leaving space for hydrogen.
5 tertiary butyl idecane has a chain of 10
Yeah.
carbons.
Yeah,
With
1,
a
2,
tertiary
3, 4,
butyl
5,
group
6,
on the 5th.
7, 8. Am I right?
We have to make this structure.
Okay.
So
We can
the-
now,
so-
because I am
so,
making the structure or
like,
you are making the
what
structure,
is it saying?
we
Is it
can
saying that
start
we have to
numbering
make
from
4?
either side. So I'm
Like,
starting from left to right.
Right now I gave you
1, 2, 3,
formula
4. My
structure
this is
and
4
you
or
are
not?
giving the name, it is opposite. Now they are giving the name and we have to make the structure. First write the first name. 4 isopropyl octane.
Okay.
Right?
And now you have to put. Okay, I'm going to put the hydrogen first. Okay, we will have put the hydrogen.
Yep.
What is the
4
isopropyl group?
isopropyl octane.
I'm writing. I'm writing this.
You know, like CH.
4 isopropyl octane. First
Or
main
are
chain
just two
contains how many
sides. It
carbons?
doesn't matter. Okay.
So the octane will be
And-
8. That's going to be the main chain, right?
Is this is isopropyl or not? Tell me.
I'm leaving space for hydrogen.
So octane is the main chain. It contains 8 carbons. Is that true?
Isopropyl, because we don't use the word secondary propyl,
7.
but for iso and secondary propyl it is the
Yes.
same thing.
Okay.
Okay.
We can now, because I am
Three
making
carbon.
structure,
Okay, now look here.
we make the
Isopropyl.
structure.
We call it
We can
isopropyl.
start numbering from
Now we have to
starting
fill the
from
hydrogen. Can you fill how many hydrogen we need here?
3, 4. Minus is 4 or not?
Oh, I'm gonna grab my pointer. I was just writing it down. So 4 isopropyl. So yeah, basically we could begin on any side. Yeah, 4 would be here. Yeah, right in the middle.
Okay. And now you have to put.
No.
Okay,
Why
I'm
is-
going to put the hydrogen first. Okay. Now let me have put the hydrogen. What is the isopropyl?
Because one
Isopropyl.
bond. Next
So
one.
that'll be
Like
that's gonna be CH3 up at the top, and then connecting to a CH bond, and then it will be a CH3 at the bottom. So it'll be methyl.
CH2. Because
It'll be methyl,
when,
methyl,
what about next?
and then this one.
Is this
Right.
isopropyl or not?
I would say CH3, CH, CH3.
CH2, very good.
Yeah,
What
I would
about
say
next?
That's an isopropyl group. Yep.
Isopropyl, because we don't use the word.
No,
secondary,
count how many bonds hydrogen is
But
making.
for iso and secondary propyl it is
So
the
only
same.
one bond.
Okay. We got it. And now look like isopropyl. Call it isopropyl.
Mm-hmm.
Now we have to fill the hydrogen.
3 because 3 bond is already there. So you just need only one
Okay,
hydrogen.
just a moment. Let's see. So isopropyl octane. So 4. So 1, 2, 3, 4 isopropyl, and then octane. So it's gonna be it'd be CH2. No, so, or C. Oh, it's gonna it's gonna be. It'll be from if it's CH3, then it.
That's correct. That's
Okay, and
yeah.
one bond makes
So
4.
it is like
So that's
sometimes they give
C, so that's one bond, and it's gonna make 1.
Yeah.
So that's 1. So it's CH3, right? Or
Yeah.
CH2 and 3, and then 4. Okay, CH2. So this is 1, and then 2 is 3, and then 1. So it'd be CH2.
And this group, always remember, this group is
So
called
this is
isopropyl
1,
group.
and then this is 1. So
CH
that leaves
and
this is
two-side
for
methyl group, right?
CH2.
Isopropyl.
Wait, okay, 1, 2, 3. So that means that one
Yeah.
more. So it'd be would it be CH or hold on? So 1,
Suppose,
2.
and suppose if it's isobutyl, then what you will do?
Okay, so 1 hydrogen will go there. Okay, okay. So right here, 1, 2. So it's gonna take 2 hydrogens. So CH2. Yep, and then 1, 2. So it'd be CH2. So then this
Here is going to
one
be difficult thing situation
two.
for us.
So
Let's
it'd
go
be
back
CH2.
here and read
And
what
this
the
is
next one they're
So it'd
asking.
be CH3.
5 tertiary
Oh, okay.
butyl
Okay.
decane, decana decane. Okay, I'm writing
Yeah,
this
after
one.
practicing going through it step by step, absolutely.
5 tertiary. Tertiary we
That
just write
helps for
TER.
sure. Yep.
5
Oh
tertiary
yeah. Yes.
butyl
So the methyl
decane. First decane
will
means how
always
many
be
carbon atoms?
at the ends to cap it off. Is that true?
Ethane also.
Oh, so propyl.
I'm writing 1, 2. Sorry, I have to put the hydrogen
Yes.
space.
CH and
Because
two
I have to
sides
put
of
them.
methyl group. Yep.
1, 2, 3, 4,
Yep. And then that'll make. And
5,
there's no charges here
6,
because all of them are. They're
7.
all.
Suppose I don't
all
have space there,
balanced.
so I'm going, doesn't matter. I'm going to 7,
If it
8,
was isobutyl,
9,
then it would
10.
be.
I can make here, it
let's
doesn't
see.
matter.
So
It's 10 or
it would
not.
be. It would look like 1, 2, 3, 4. It wouldn't be 1, 2, 3 like that. I think it would be. Hold on. It would be.
Let's go back here and read what the next one there are. 5 tertiary butyl decane.
Numbering can start from us.
I'm writing this one. 5 tertiary. Tertiary we just write TER. 5
You can go by either way, doesn't matter.
butyl.
Normally I prefer like the regular
First
numbering
decane
system.
means how many
From
carbon
left
atoms?
to right.
Decane means. Let's see.
Ethane also.
Decane is 10.
What? Yeah.
I think 1, 2. Sorry, I have to put that
Tertiary.
space because I have to put the 1, 2, 3,
Ter means what?
5, 6, 7. Suppose I don't have space there, so I'm going to doesn't matter.
No, just look the tertiary group. Here you have to look. You have to look this one.
Take here, it doesn't matter.
No hydrogen, that's right. Am I right?
Yep.
And
let's
butyl
see,
has
so-
how many carbon
Let's
atoms?
see. So 5 terbutyl decane. So decane is our
Butyl
main
has
chain,
how many
which is
carbon
10.
atoms? 3.
5 would be at the
Oh,
fifth
sorry, total
branch.
4. Am I right?
Since there's 10, it doesn't
I'm
matter which
putting
side.
like this,
So
look.
1, 2, 3, 4, 5.
This one.
1, 2, 3,
This
4.
carbon
Let's
is
see,
tertiary or
5.
not?
1, 2, 3, 4, 5, 6, 7, 8, 9,
Is-
10. 2,
And
3,
is
4,
attached with the
5,
fifth number of the
1,
main
2,
carbon, main
3,
chain,
4,
right?
5.
So that's the
Doesn't
tertiary.
Okay, so it
And
doesn't
you can
matter
fill the
in this
hydrogen.
case.
Normally I prefer like the regular number.
But how many hydrogens
Okay.
from the beginning?
So 1, 2, 3, 4, 5. So we could begin here at 5. And so right here will be a butyl, butyl. So terbutyl. So tertiary.
Good.
So this is 1, 2, 3. So that means that there's no hydrogen here, right?
Just look at tertiary group. Here you go. You have looked this one. No hydrogen, that's right, right? And butyl has how many carbon atoms? Butyl
3.
has how many carbon atoms? No, sorry, butyl
4. 4.
I'm putting like this. This one. This carbon is tertiary or not?
Tertiary it is because it has no hydrogen to it.
And is attached with the fifth number of the main carbon, main chain, right?
Yes.
That's right.
Oh, 5 tertiary. Okay. Beautiful. And that means that.
Yeah, because I am starting from the basic everything so that you will understand everything. Because
How many
gradually we are
hydrogens
also
in the
going. This is
beginning?
called
Just a second.
condensed formula. This is
So
called
decane.
condensed
So, well,
formula.
I have to figure out.
Then
So if
also
it's
in the
3
future, like after
over
doing
here
completely,
and 3 over here,
once you will understand
so
this, we will also
CH3
going to do the line
and
formula.
1 and 1. So it's going to be
Now
CH2.
no, it's once, but
This
before
is
if I will
1
start
and
line
1, so
formula
this will be
now,
CH2.
you are not going to
This
understand
is
main thing.
1,
Okay,
2.
that's why
So it'll
first
be
I'm not using the
CH2.
line formula.
This is 1,
We'll use
2,
later this
3.
one. First you
So this
understand
will be
these things.
1H
Okay?
CH. This here would be
Don't worry.
1, 2.
So I'm going to
So
stop
it'll
here
be
today.
CH2. This carbon,
So
1, 2 bonds, so CH2. This carbon 1, 2 CH2. This carbon 1, 2 CH2. And then this one here has got 1 bond, so it's got CH3, and it should be complete.
That's right.
And this is okay. And that's how we're going to be able to
and
fill
also one
those
more thing,
carbons
John.
in. Okay.
Like if you want to
Okay.
share with someone to
Basic,
Okay.
divide the expenses, it's okay for me. Okay.
because gradually we are also
Yeah.
going. This is called
If you want like that, it's up to you.
condense.
I was wondering how many hydrogens do I put, but really it's okay. I can tell from the bonds.
Okay, then no problem.
Like after doing
I will
We're all
work.
doing alkanes, so it's
Don't worry. I want you.
we are also going to do the line form.
okay. Is that
Okay,
harder?
no problem. Like in future, like when your class start,
Before
if someone wants to join, you already have a better foundation. Am I right?
Okay.
that's the first I'm not using the line formula.
Okay.
Okay. Because in that up to that time, you are going to be very strong
I like this,
foundation
learning
there.
all this stuff.
Once you have a strong foundation, it's very easy organic chemistry.
Okay.
Okay.
Very good. Yeah, this was a lot. I took a lot of notes, organized notes,
And good.
and then I'm gonna go back, and I'll be able to.
And that's
copy
good
down
that you
these
started early
examples,
because
and these were all
when you
great.
start during the session, I
Very
can't go
good.
in detail
Okay,
because you
thank
have
you.
less time. I
I
will.
appreciate it.
It's better you start right now so I can build a
Mhm.
strong foundation for
If you
you.
want to share with someone to divide the expenses, it's okay for me.
Okay.
If you want like that, it's up to you.
Yeah, I'm gonna.
No problem.
I think I'm the only one that's really motivated to do it. A lot. Not many other students. I don't know.
Okay, no problem. Like in future, like when your class start, if someone wants to join, you already have a better foundation, right?
Oh no! Absolutely, I will offer that.
Because in that up to that time, you are going to have a very strong foundation there. Once you have a strong foundation, it's very easy organic chemistry.
Excellent, excellent. Well, I will definitely, put your name out there with anyone that would
And that's good that you started
use it.
early. When you start doing the session, I can go in detail because you have less time. I will think it's better you start right now so I can build a strong foundation.
Right. This is great. Excellent. Okay. Well, thanks so much. Today's lesson was great, and I'm gonna give you a call tomorrow or so, and we'll set up a time for another session. Okay. Sounds good to me. Have a great evening, Joffrey. Thank you.